Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic, finding missing sides and angles using the law of sines. Now, the law of sines is also referred to as the sine rule. So if you've heard of any of these names, we're going to be covering that topic today. If you're new to my channel, there'll be time codes in for this video in the description box below, so be sure to check those out and skip ahead to whatever part of the video interests you the most. If you find yourself with any question about what we see here today or even your own homework, remember you can always put them in the comment box below. I'd love to be to help you as much as I possibly can. However, if you feel like the comment box is a little bit too small, feel free to visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like. It really helps the channel and I can't express how much I appreciate it. Also, don't forget to hit the notification bell, smash the subscribe button, and share this video with a friend. Well, without further ado, let's talk a little bit more about the law of sines. So before we can talk about what the law of sines is and how to use it, we have to talk about when we use it. So generally speaking, when do you ever need to use the law of sines? Well, this question is going to be answered with one simple question. Do you have a right triangle? If you can answer yes to this, you're not going to use the law of sine. Instead, you're going to use something called the Pythagorean theorem or SOHCAHTOA. These two things are going to be covered in other videos, not this one, but if you have a right triangle and you need to find missing sides or angles, this is what you're going to be focused on. So that means if you answer no to this question, there is a good chance that you might have to use the law of sines, which is also known as the sine rule. But that's not the only thing that you can potentially use. There's also something called the law of cosines. The law of cosines is also not going to be covered in this video. We'll do that in a different video. But you see, in general, if you have a right triangle, you're not even going to look at the law of sines. You're going to be looking at something else. So when you have something other than right triangles, that's when you can start thinking about, hey, maybe I need to use the law of sines. So let's say you don't have a right triangle. You still need to figure out, can you use law of sines or maybe this other thing, law of cosines? So let's get a little bit more specific. We don't have a right triangle, but what do we still need in our triangle in order to use the law of sines? And to illustrate that, let's use a few illustrations. Here we have 6 triangles, and I've denoted their sides and their angles with capital and lowercase letters. These sides are going to have the lowercase letters. So sides are lower, and the angles are going to have the uppercase letters. So this is a uppercase C, that is a lowercase c. Uppercase B, lowercase b, lowercase c, lowercase a, b, and c. All the sides are lowercase letters, and the angles are denoted with the uppercase versions, and that is very intentional. So we have 6 triangles that kind of give us an idea of the types of triangles we can potentially run into. So the first triangle we have is a triangle in which we know all the sides but none of the angles. This is a triangle that we cannot use the law of sines for. So don't even try. If you're given a triangle with all the sides and none of the angles, you cannot use the law of sines. Let's look at our next triangle. Here we have 2 sides and an angle in between. So we have an angle sandwiched between 2 sides. This is going to be a situation that is also not good for a law of sines. You can't do this. If you have 2 sides and 1 angle, that angle can't be in between those 2 sides. And that will be more apparent when we start talking about the law of sines directly. But for now, just note, if you have 2 sides, the angle can't be in between them. This is not going to work. Our third one, we have 2 sides again, but notice the placement of the angle. It is no longer in between the 2 sides, it's over here. You can almost see that it's opposite this side here, and that's also intentional. This is a perfect triangle to use the law of sines. 2 sides given and an angle given that is not sandwiched between those same 2 sides, is the exact type of triangle you're looking for when you're doing the law of sines. How about this triangle, our fourth triangle? We have two angles this time and one side sandwiched between the two angles. Can we do that? We saw here we couldn't have an angle sandwiched between two sides, but can we have a side sandwiched between two angles? And that is going to be a big yes. You can do this, and I'll show you how a little bit later. But no, if you have two angles, you can have a side sandwiched between it. How about this one? We have two angles again, and we have another side, but it's not sandwiched between the two sides. Can you do that? Yes, we're going to be able to do that as well. When we have two angles, it really doesn't matter which side we have because you can always find that missing angle. And that is going to be key, especially when you're doing the law of sines. It doesn't matter, as long as you have two angles, you can always find that missing angle if you need it in order to make your law of sines work. So this is going to work and this is going to work. How about our last triangle? We have three angles but none of the sides. This is going to not work for the law of sines, and it's actually not going to work for anything. You can't find a missing side when you're giving all angles. So this is not going to work. So when we talk about triangles that are not right triangles and trying to figure out when we can use the law of sines, you will see that there are some types of triangles that definitely will work and some type of triangles that definitely will not work. So let's summarize our illustration with some shorthand notation. So if you remember what we just said, whenever you're given all angles or you're given all sides, you're not going to be able to use the law of sines. So we're just going to ignore that situation and focus on whenever you're given two sides and an angle, or you're given two angles and a side. And if you recall, when we had two sides and an angle, we could not have the angle sandwiched between the two sides. And that notation would be something like this: side, angle, side. We can't have that. We can't have a sandwich when we have two sides and an angle like this. We have to have the angle on the outside. So we have two sides and an angle. We have to have the angle on the outside. It can't be sandwiched in between the two sides. So this is the notation for when you have two sides and an angle that's going to work to use our law of sines. Whenever you have two angles and a side, you're going to have two angles. Remember, we can have a sandwich for that, or we can have this. So it can be sandwiched or it could be following. It doesn't matter whenever you have two angles and a side. Remember, because we said you can always find that missing angle to fill in whatever part of the law of sines you need. So these are going to be the three situations that you can use the law of sines. This one is going to be handled by a different method. Hint, hint. I'm winking right now, by the way. So we talked about when to use it, but now we have to talk about what is the law of sines. So when you're given a triangle like this with angles A, B, and C, remember, uppercase is going to be the angles. Just like before, lowercase going to be the sides. So when you give an angle A, B, and C, and A, B, and C for the sides, you have the law of sines set up here, in which sine of angle A is going to be over the opposite side, lowercase a. And sine of angle B is going to be over the opposite side, lowercase b. And sine of angle C is going to be over the opposite side, lowercase c. Whenever you have these ratios, this is what we call the law of sines. And this ratio is going to be true for all of these angles and sides that you have for a non-right triangle. So if you're given some information, using the law of sines, there's a very strong possibility you'll be able to find every missing part of your triangle. So you might be wondering, why are these grouped in this fashion? Why does sine big A have to be over little a, and sine big B over little b, and likewise sine big C over little c? And that is because of the relationship between these sides and angles. The side opposite your angle is going to be directly related to the angle itself. As you increase the size of that angle, that side is going to increase as well. As you decrease the size of this angle, this side is going to decrease as well. No other side is going to be affected by this angle moving, so this ratio is going to be preserved based on how the angle and the sides are reacting. Here's a quick visual. So let's say you have a triangle with these three sides. Now I'm not going to put something here because I want you to see how that side increases and decreases based on how this angle moves. These sides are pretty fixed, so they're not going to be growing or shrinking, but you see that if this angle denotes this triangle side here, if we increase that angle, these sides are not moving anywhere. They're not changing length, right? But you see this side got much wider. If we get a little bit wider, once again, these are staying the same. This side is getting much wider. If we decrease it, if we have an angle shrinking like this, you see this side also gets small. So if we're going to be talking about ratios, this side is the only one that's going to be related to this angle. So the opposite side of that angle is going to be the side that is kind of related to or depends on that angle. Hence why big A is going to be over little a. Big B is going to be over little b, and big C is going to be over little c. Another thing to realize is you don't have to actually write your law of sines like this. Some people prefer to use the reciprocals because that might be a little bit easier to solve. You're kind of eliminating some work. So if you want to do little a over sine of big A equals little b over sine of big B equals little c over sine of big C, that is perfectly fine. As long as you're not mixing and matching and having one sign in the top, one sign in the bottom, this is completely fine. Whether you write it like this or you write it like this. It's all the law of sines or the sine rule. So we talked about when to use it and we talked about what it is, but now we need to talk about how do we use it to find missing sides or angles. So here we have our question of the day in which we're given this triangle that we have two sides and an angle, and we're trying to find this angle x. And I've written our law of sines over here for reference. So one thing I recommend as you're starting to really get more familiar, more comfortable with the law of sines is to label your triangle. Use the capital letters and the lowercase letters so you can know where things fall when you're trying to plug them into your formula here. So I'm going to name this angle A. This is going to be angle B, this is going to be angle C. And because we draw our angles in this way, we know that opposite these angles are our lowercase letter sides. So angle A means that this side is going to be A. Angle B means that this side is going to be B. And angle C means that this side is going to be C. So this kind of gives me a picture so that I know when I'm trying to plug things in what I actually have. So we need to find X. So let's plug everything in to our law of sines and see what part of this do we need. We're only going to ever use two pieces at a time. We're not going to use all of these at once, just two pieces. So we're going to plug them in to see which two pieces are going to be the ones that we need to focus on. So we have sine of A. We don't know what A is, so we're going to rewrite sine of A. We don't know what little a is, so we're going to write that A here as well. Sine of B. We don't know what that is, but we know that's sine of x, right? We're trying to find that. But we know what little b is, right? We know that's 22. And we know that sine of c, well, c is 42, so the sine of 42, and it's going to be degrees here. And we know what little c is, right? Little c is 17. So when we plug everything into law of sines, you see that there's one thing that we really have no information for. There's nothing here, so we don't want to use that. That's not going to help us get anywhere near finding what our x is, and that's just going to be a waste of just brain power trying to figure out how to make that work when you really can't. So we're left with this, and you realize another thing about the law of sines. In order to have something that works, you need a whole ratio and at least a part of another ratio. This didn't work because we had a whole ratio, but we had no part of this ratio that we knew. This one, we at least know what the side is, so when we pair it up with a whole ratio, we can get our answer. This, we had nothing, no angle or side. So whenever you have a whole ratio and a partial, that should be your sign of, hey, this is what we're going to use for our law of sines. So let's rewrite this without this extra baggage here. So we have sine x over 22 equals sine of 42 degrees over 17. And we need to solve for our angle x. So the first thing we want to do is get x by itself. So we can just start by multiplying this 22 to this side, and we're going to have a sine of x equals 22 times the sine of 42 degrees all over 17. Now, how do we get our x away from this sine function? Well, since sine is a function, we can apply the inverse of this function to both sides. Remember, whatever you do to one side, you always have to do to the other side, making sure that everything stays consistent. So, in order to get x by itself, we're going to apply the inverse of this, which is known as sine inverse, to both sides, and that's going to give us an x equaling the inverse, right, denoted by this -1 here, of all of this. So 22 times sine of 42 degrees all over 17. So this is what x equals. This is exactly what x equals. But you can plug this into your calculator and you can get a rough estimate of what x is if you round it, let's say, to the nearest tenth. So let's do that. Plug this in, making sure that your calculator is in degrees. You don't want it in radians. That's going to give you the wrong answer. Making sure your calculator is in degrees, and this is inverse sine. So you might have to do a little bit more to get that inverse trig function, but you should be able to handle that with your calculator as well. So plug all this in, and when we do that, we get 60 degrees. So this is going to be approximately 60 degrees, right? Because we had to round. It's really like 59.989, yada, yada, yada. But if we do it to the nearest tenth, all of that goes away, and we have roughly 60 degrees. So our x is going to be roughly 60 degrees. So that is our answer. X, I don't want to say equals. Let's say just approximately 60 degrees. And this is an angle, so make sure you have that degree there. So I hope you're following to the examples, and I hope you understood when you could potentially use the law of sines when you compare it to the law of cosines or SOHCAHTOA or even the Pythagorean theorem. If you have any questions, if anything confused you, or even questions about your own homework, remember you can put them in the comment box below. I would love to be able to help you as much as I possibly can. However, if you find the comment box a little bit too small, feel free to visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. I can't express how much I appreciate it, and it really helps get this video to other people who may need the help. Also, don't forget to hit the notification bell, smash the subscribe button, and share this video with a friend as well. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.